Hello, math fans. Continuing my short series on cribbage. Again, cribbage is this. Watch my previous one for if you need a primer on cribbage. But ultimately, I'm assuming you know a little bit about the how you score a hand. I just wanted to discuss a few random stats and then introduce this random math question that my son and I started asking ourselves many years ago, and then we worked on it for a few weeks and then set it aside, and I'm returning to it now. But there are lots of studies. I mean, if you search online, Wikipedia has tables like this, like what are the probabilities of each type of hand. It's really something you can count pretty well. There are some challenges in the counting, but I just wanted to mention a few classic cribbage stats in case you had never heard of these. So 29 is the maximum score you can get for one hand. That's why often you'll see boards that are made in the shape of a number 29. What we mean by hand is you have a starter card that's flipped over, and then you have the four cards in your hand. So the question becomes, what is the best you can do? And ultimately you find that you can get a lot of points. And this is just a small, somebody who's seen this before. Pretty much if you have a lot of fives, you're going to get a lot of points. But in particular, if you get a jack that's the same suit as this five, let's say it's a five of hearts, and this is the jack of hearts, you get one additional point for having a jack, for my knobs or whatever we say, and then you have all the other fives. So if you have a hand with three fives, you're doing pretty dang good no matter what. But this is going to get you a lot of points. Just to review the counting, you have four of a kind. That's going to be 12 points. So that already bumps you way up. Then you have a whole bunch of 15s. 15-2, 15-4, 15-6, 15-8. So 15s. And I didn't even count them all. What did I forget? So that was 15-8. There's a bunch more. 15-10. That makes 15. And basically you're going to pick whichever one you leave out. So if you take these three, that's 15-12. Now we're at 12. If we take these two and this one, that's leaving this one out. That's 15-14. And then the only one we haven't left out is this one here. So these three. So again, 15-2, 15-4, 15-6, 15-8 for the jacks and the fives. And then 15-10, 15-12, 15-14, 15-16. 16 points. That's where you get all these points. So again, what I was saying is, this is our first example of this useful counting idea. Sometimes it's useful to figure out which one is missing. So there are four ways you could remove one of the fives. That's why I knew there were four 15s that could be made from the fives alone. That's 28 points. And that's practically it really is the high score, except for the fact that you get this one for your knobs with this jack. Jack of the same suit as the five. It's extremely rare. So this is I'm getting from Wikipedia. They list it as a 1 in 216,580 chance. And there's always the question of, is that a random hand? Is that after you've made your choices? Is that a two-player game? So, I think there's some caveats there. But that's why we say 29 is the max score. Now, technically, the dealer's 30 is if on the flip there's a jack, you get 2 points for that immediately. So that's usually not counted as part of the counting hand. But if that were the case and you had fives here, then you'd get 2 when it was flipped. And then you'd get 28. So you'd actually get 30. And that's they list it as somewhat more likely than the others. 28 is the second highest score, which is basically this score without the knobs. So basically a 10 anywhere in those five, and then the rest fives. 24 is the third highest score. There's some random things. These are what they are. You can't have a 2. or a 10 in there to get a 24. It's really weird that you can't have a 24 with a 10. And again, there's so many questions you could ask, but all those questions have already been asked. These scores are impossible. You can't get 27, 26, 25, or 19. Supposedly if someone calls a score of 19, there's some name, Muggins or something, and they lose everything. I can't remember. Sometimes jokingly you can say, I got 19 when you got 0. It said there's just under 13 million hands. The average score is 4.7. But that includes randomness. If you're actually removing your 2 worst cards and then you score, it's going to be higher. And it said the average is around 8 for the dealer and the other person, the pwn. And the average for the crib is usually a little worse than the overall average because you're typically given 2 bad cards. These are two other facts that I read about that I'd never heard of was if you have 4 aces in your hand, which is worth 12 points, nothing that flips will help you. A 10 doesn't help you. There's no way you can make a 15, so it doesn't matter what flips. That's kind of a random thing. There's 71 distinct ways you get a 15, which can be tough. I found this on Wikipedia as well, the different ways you can get 15. So there's so many little questions you can ask. And ultimately, I think this is a great exercise in counting fundamentals. So if you're going into probability or if you're going to play a lot of card games, I think Cribbage can teach you some good counting fundamentals. All right, so let's go to this problem. So my son was like, well, what if you just took the entire deck and laid it out flat? So you wouldn't have a starter card. You would just have all 52 cards sitting in front of you. And you took the normal Cribbage scoring rules. How many points would you get? And we had to think about it a long time. Even, using all my tools, it was not, it's much larger than 29. But an interesting thing, now that I've returned to the problem, it turns out the hardest one is the 15s. By far. As I'll explain, and I'll talk about this. I'll probably make a separate video about the 15s because I've had a few. They're not breakthroughs. I'm sure people have come up with these sorts of ideas before. Breakthroughs for me, where I got to even use polynomials and power series. So there's some interesting things, but that's more of a advanced lesson. But my number, I only found one place online where somebody else had studied this, and my number very slightly differs from theirs. And I'm worried I might be wrong. Overall, our numbers are within we're very close. But I'm curious if someone finds my error or wants to take this further. I'll keep thinking about it. As I say in some of my other videos, I'm kind of happy when I'm wrong. I'll learn a lot from it. But I just wanted to talk about a few counting principles here, and then I'll talk in a separate video about the 15s. So 4 of a kind. Ultimately, what we're just trying to do is to count. But that one's fairly straightforward, because you're going to have 4 aces, or 4 twos, or 4 threes, or 4 fours, all the way up to 4 kings. That's why there's 13 ways. Each suit has 13 cards. So that one's fairly straightforward. Each one gives you 12 points. So not much changes there. The runs does change, because if you think about having there's a big problem there, if you didn't realize this, in terms of counting. So yes, you can have a run, and the run is counted as the number of points. Let's talk about runs for a second, talk about some counting principles. So that would be a run, and it would be worth 13 points if we're using the rule of number of cards in the run. I should 13 points. You're like, why is it 13 points? 11 is not 11, it's Jack. 12 is Queen, and 13 is King. So that's 13 points. But when we do runs, we count every combination. It happens a lot in Cribbage where you get like 4, 2 5s, and a 6, and we call that a double run. And you get points for this run, and you also get points for this run. And sometimes you get another card. Like if you got another 5, then you have all sorts of runs. 4, 5, 6, 4, 5, 6, 4, 5, 6. You get a lot of points. Okay. And they don't have to be the same suit. So how do we handle things like that when we're counting? Well, what we think of is, okay, we now have 13 slots. The first slot we're trying to fill with an ace. The order doesn't matter here, but we're trying to put a hand together, and we want an ace in the first spot. So there are 4 ways to do that. You can have the ace of hearts, the ace of clubs, the ace of diamonds, the ace of spades. How many ways can you get it to? There are 4 ways. Now, the best way in my mind to visualize this is with a tree. So if you were constructing every possibility, you would have 4 branches to start with. You'd have the ace of hearts, you'd have the ace of clubs, whatever. You'd have the ace of spades. Aren't my drawings good? And you would have the ace of diamonds. From each of those now, you have 4 possible things for a 2, and you start to build this tree. And you start to realize after 2 steps, the number of branches is 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And the choice for the first one doesn't affect the choice for the second one. So this is this law of independence. But it should, the rule is you multiply. And this comes up a lot whenever you're trying to count things. So at this point we say, well, the number of ways you can do this is 16, 4 times 4. If you want to say there's 4 ways you can do this, so then you'd multiply by another 4. And the number of ways you can do this is 4 ways. Number of ways. So it's 4 times 4 times 4 times 4, 13 times. And that's this ginormous tree. How many branches at the end of that tree are there? Well, that is 4 to the 13th, which is an absolutely astronomical number. And it's all these combinations. This is important. We use this every day. I mean, if you want to think about other examples, think of phone numbers. How in the world are there enough phone numbers for everybody? Think of license plates. Well, for phone numbers, you have 10 choices for this. 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 You have 10 for that. So the number of possibilities is 10 times 10 times 10 times 10 times 10. It's a big number. And then you have the area codes. Makes it even bigger. And that number is far more than the number of people. Same thing like social security cards or license plates. With license plates, it's even easier to say there's a lot of stuff because we allow numbers and letters. And if you allow numbers and letters, then the letters give you 26 choices and the numbers give you 10, 0 through 9. So it's going to be 36 times 36 times 36 times. It's a really big number, and that's why we don't easily run out. That's what you have to think about in counting. So anyways, each of those is going to get 13 points, and that's the lion's share of the points from your deck. But surprisingly, that's one of the easiest to count. It's a typical independent multiplication probability problem. Flushes. We could argue about this. To me, a flush is if you only have that suit in your hand. So if you're holding all the cards, it feels weird to say flush. But let's pretend that you can pick up whatever you want and count. So if you pick up all 13 diamonds, you're going to get 13 points. If you pick up all 13 hearts, you're going to get 13 points. So anyways, those are really not up for debate. When I look online, they'll know the person that appears to have posted about this in a place where I was able to search and find it, had those same numbers. The 15s are the challenge. Why are they such a challenge? Because there's so many ways you can get 15. And what bothered me when I first thought about this problem is I knew there had to be a nice way to count this, and I was unwilling to ask any of my colleagues or anything. I just kind of thought about it for fun. So I put in some time, I had some ideas, and then I set it to the side, and I never did anything about it. So I have some notes. This is from a posting online, a Reddit post. That's the only place I could find anything about this. The person had just listed them all, and they had done ace, 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 2, 2, 2, 2, 3. And I love the diligence, and I appreciate this post, this Reddit post. It's, I don't know who it was or anything, but there's a counting principle in here, and they said times 4. Why did they say times 4? Well, there's only one way to have all aces and all 2s, but there are 4 choices for 3. So all of these have to be multiplied by the number of possibilities. So there's 4 of those. Okay, on to the next one. And you just try to list them all. And that was the strategy used by the person who posted this. So there's only one way to have 4 aces, But how many ways can you have 3 2s? If you're trying to think about the number of ways you can have 3 2s, there's 4 ways. Because there's 4 ways you can say, I'm going to not have a 2. And then you say, how many ways can I have this 5? Well, there's 4 ways to do that, and that's where the 16 is coming from. So you can see these counting principles at play. Now, an interesting thing that happens here, so pretty much if you're going to take the 2s, let's just take them, and you have heart, I'll not try to draw it again, spade, diamond, club. If you're going to pick 3 of them or 1 of them, there are 4 ways. There are 4 ways to pick 3, and there's 4 ways to pick 1. You could pick this one, that one, that one, or that one. But the number of ways to pick 3 out of this group, the moment you pick 3, you've selected one to not be in the list. And so you say, well, what if this isn't in there? Then it's those 3. What if this isn't in there? This is called choosing. We call this 4 choose 1 and 4 choose 3. It turns out those are always the same. 1 less than the number and the number 1, and they're both 4. So the interesting is, how many ways can you get 2? 4 choose 2. And there's more than 4. So you could have, let's just start listing them. You could have heart and spade. You could have heart and diamond. You could have heart and club. You could have spade and diamond. You could have spade and club. You have diamond and club, and it's 6. And there's a lot of formulas for this, but it turns out, after thinking about it, those are the only 3 things we need to know. And you're going to see these happen immediately in the next one. So there's only one way to pick all 4, and that's sometimes called 4 choose 0 or 4 choose 4. Those are both 1. Anyways, there are 2 right here. That's 4 choose 2. So there's 6 ways to do that. There's 4 ways to choose this 3. There's 4 ways to choose 1 4. Times 4. So that's 24 times 4 is 96. So to me, this analysis looked good that this person did. They just went through and listed them. But it's hard to make sure you don't miss one. So it's very diligent work making sure you don't miss any. So then they did the next one, just checking the counting here. We have 6 ways you could pick your 2s, choosing 2. You have 4 ways, so this was 6 times 4, and that's where the 24 came from. But look at the extreme list here. First they did all the choices that have an ace. Then they did the choices that have a 2. There's only a few choices that only have 2. And they said there were a total of this many. And my number's a little different, and I don't know that I'm right, and I don't know that they're right. And then each one of those is worth 2 points, and so that's where they got that number. But I hope you're kind of seeing the principles at play is you're trying to count all the unique possibilities and then count the number of ways that can happen and then add it all up. So in a separate video, I will show you how I got my number. This is their number from this online post, Reddit post, how I got my number, and I hope someone wants to take this up. But the other thing I want to show is, besides the principles of how we do these things, I want to show some other tools for counting. So in the next video, I'll talk about how we use polynomials and Taylor series. So that's going to be a much more math speak video. So that's why I'm putting it to another place, and I'll explain this number I got. And I hope someone finds the difference, because I've just been doing this research today. I can see many of the things match up. I can't figure out why our numbers are slightly different. My number is that. And the other issue is I'm using an online calculator. So it could be that there's a rounding issue or something. And I'll check this later and add another video. But we're off by a little bit. That one's just under 17,000. And I am just over 17,000. I haven't been able to explain the difference. All right, I'll talk about that in the next video.